Welcome back, chemistry fans. I'm going to now finish up the test, start the test, depending on how you've gone about the order of this, for the multiple choice portion of exam number 2. Let's jump into this right now. Dink, dink, dink. All right, here we go. Number 1, one of the naturally occurring isotopes, potassium, has a mass number of 41. How many protons does it have? Well, you just have to look on the periodic table and find that potassium is element number 19. That's your answer. Calculate the percent error if you have a final mass of 2.41, but ended up having 2.11 in laboratory. So should have had. So that's the correct answer. Now this is absolute value, so it doesn't matter which value you put on top, which one you put on bottom. So 2.34 minus 2.11, or reverse, whatever it is, it's absolute value. It ends up being 0.23 divided by 2.34, and you get roughly 9.8. with the sig figs somewhere in that range, 9.83% error. All right, number 3, percent composition. You have 64 grams of sulfur and 152 of sodium. So 64 and 152. Add those together. 64 plus 152, and you get 216. So I will do 64 divided by 216. And you get 29.6% sulfur. And so if we do the other and there's one more. Oh, man. So this is live television. You can tell because I just screwed it up. And there is, no, I did do it right. Shoot. So 29.6% sulfur. Let's try the other one. 152 divided by 216. So 152 divided by 216 gives you 70.4% sodium. All right, those are your 2 answers. All right, number 4. Let's see here, zoom this in a little bit. What is the percent composition in this compound if you have the weights given to you? So this time we're trying to add up their weights from the scratch. So I got 36 for carbon, and I have 8 for the hydrogens, and that's 44. So 36 divided by 44 would give me the percentage of carbon. And if I did 8 divided by 44, it'd give me the percentage of hydrogen. So that's what it specifically asked for, 8 divided by 44. So I've got 18% hydrogen, 18.2. All right, empirical formula. So it's asking you to do a little calculation here. So first step, convert percents into grams. For hydrogen, it's 1. For carbon, it's 12. So I'm going to do 17.34 divided by 1 is 17.34. 82.66 divided by 12. 82.66 divided by 12 is 6.89. I'll divide both of these by the smallest. And you get 2.5, and you get 1. Well, that's not whole numbers, so I need to multiply them by 2. And so my answer is C2H5. All right, molecular formula. So this is going through the exact same process, but this time I'm giving you the weight. So I've got 46.16 grams of carbon, 5.16 of hydrogen, and 48.68 of fluorine. So 46.16 grams of carbon divided by 12, 5.16 divided by 1, and 48.68 divided by 19. So let's do these first math here. 3.85 5.16 and 48.68 divided by 19. 2.56. Divide each of these by the smallest. 3.85 divided by 2.56 gives me 1.5 is 2 and 1. Now those are not whole numbers, so I need to multiply them by 2. So I get 3, 4, and 2. And those are for specifically carbon, hydrogen, and fluorine. Okay, now we got to add up their weights and see if it comes up to be 156. 3 carbons is 36, 4 hydrogens is 4, and 2 fluorines is a lot. 78 is the total weight. That's not equal to 156. So I'm going to take 156 divided by 78. And I get 2. So therefore, I need to double this formula. So my final answer comes out to be C6H8F4. All right. Formula that shows the simplest whole number ratio of atoms in a compound is the mole ratio by definition. Determine the molar mass of an element. One must know to determine the molar mass of an element, you must know the atomic mass, maybe? I don't know what question 8 is. Let me go back and check the actual question on the test exam, because that does not make sense without the multiple choice questions here. All right. Atomic mass it is. So I am smart even though I don't look at atomic mass. All right. Number 9, the empirical formula. Just simply reduce this, C3H4O3. It's that simple. All right. Now number 10. How many atoms? So let me blow this up. How many atoms are there? Well, you didn't need all the atomic mass stuff. All you got to do is add up all these weights. There are 5 atoms inside those parentheses times 3. That's 15. There are 4 atoms inside here times 2. So we get 23 is the number of atoms. All right, what element is represented by this graph of the spectroscopy, mass spectroscopy? Well, you know it's got to be somewhere in between these. And the element that is somewhere in between these is chlorine. Now it asks, okay, well, how many neutrons are there for the lowest one? Well, if this is its mass number is 37, and we know that the atomic number of chlorine is 17, that means the number of neutrons, you subtract them and you get 20. All right, the substance with definite shape and volume is in the solid phase. So it has a definite shape and a definite volume. It has to be something that's fixed, and that means the solid phase. All right, 14. Which of the following is a chemical property? Dissolving, you can reverse if you dry out all the water. Freezing, you can melt, you can reverse it. And buoyancy just means to float. Which of the following is a chemical property? It is rusting. Rusting actually turns metal into a metal oxide. All right, so this is everything for the test. Thank you so much. I will talk with you again soon. Farewell.